Hello and welcome to Mr. Tompkins EdTech. This video covers topics most likely to appear on the calculator paper and focusing on calculator methods for solving GCSE Maths problems. For students following AQA, EDEXCEL and WJEC exam boards, the calculator papers are papers 2 and 3. OCR number their papers differently and their calculator papers are papers 1 and 3 for foundation and 4 and 6 for higher tier students. I'll be covering all the essential crossover topics appearing on both foundation and higher tier papers, so this video will be great revision for both foundation and higher tier students aiming to get a good pass at GCSE. If you missed it, make sure you check out the other video which focuses on the non-calculator skills. You'll find a list of all the topics covered in the video description below, along with timestamps to help you navigate through the video. As you progress, I highly recommend you use the topic list to make a list of any topics that you're not sure about. Afterwards, you can then look up those topics in your revision guides or simply follow the links provided to more focused revision videos on those topics. If you find it helpful, please do like and subscribe and share it with your friends. The more past paper practice you do, the better prepared you'll be for the final exams. You'll find video walkthroughs of pretty much every exam paper on my channel, along with revisions, resources and question compilations on all those key topics you struggle with. Make sure you check those out, as this video on its own is no substitute for thorough preparation. As we run up to the exams, I'll be posting important information, predicted questions and general support and encouragement to help you achieve your target grade this summer. Good luck in your preparations and in your exams. Let's get into it.
Write 120 as a product of its prime factors. Okay, so this is the calculator paper, but if you don't have a calculator paper or if you don't have a Casio calculator, you're going to have to do this a long way by breaking the number down into factor pairs. All you got to do is think of two numbers that multiply together to give you 120. So I could pick 2 and 60 or 3 and 40, doesn't really matter. I'm going to go for 3 and 40. Now 3 is prime, so that's a stopping point. 40 isn't, so we can continue to break that number down. So we need to find two numbers that multiply together to give me 40. I could pick 2 and 20 perhaps. So 20 and 2. 2 is prime, so I'm going to stop on that one, but 20 isn't, so I'm going to keep breaking it down. Two numbers that multiply together to give you 20. 10 and 2. So 2 is prime, so I stop on that one. And then finally I've got 10. Factor pairs of 10, 2 and 5. Now both 2 and 5 are prime, so I've kind of come to the end of breaking my number down. So then the product of my prime factors, I can say 120 then is all those endpoints multiplied together. So all of these multiplied together will give me 120. Okay, so what have I got? I've got 1, 2, 3 2s, haven't I? So that's 2 times 2 times 2. And then I've got a 3. And I've got a 5. Okay, now you can rewrite that in index form if you like. Just write a bit neater. 2 cubed times 3 times 5. Okay. But as I say, if you've got a Casio calculator, you can just type it into your calculator. If you enter the number 120 and press equals, and then press the fact key, it will do this for you in one step. So yeah, that kind of takes the hard work out of it, and you just need to write the answer down for 3 marks. Amazing. So if you've not got yourself one of these Casio calculators, I highly recommend them. You can find a link to it on my my Amazon shop page. I'll put a link in the video, and you can jump there and order yourself one if you haven't already got one. All right, let's move on. Question 19. Cola is sold in packs of 6 and packs of 8. And we can see various prices here. So 1 pack of 6 costs £1.95, or we can buy 2 packs of 6 for £3.50, or we can buy 1 pack of 8 for £2.64 and 2 packs of 8 for £5. What we need to do is work out the cheapest way of buying 48 cans of cola, and you must show your working. Okay, so I think the easiest way to approach this is to work out the unit cost of 1 can from the 4 various deals we've got on offer there, and then work out what the best deal is from that. Now we want to buy 48 cans altogether. 6 is a factor of 48, as is 12, as is 8, and as is 16. They all go into 48, so we can just buy enough packs of the cheapest pack type to get us up to the 48 cans. So just knowing the unit cost of each of the 4 deals should be sufficient for this question. So let's take the 1 pack of 6. So for my 1 pack of 6, so I've got £1.95, which I need to divide by 6. So 1.95 divided by 6 gives me a unit cost of 0.325. So that's the cost of 1 can, isn't it? So then we've got a 2 pack of 6, so that's £3.50. So 2 packs of 6 would be 12 cans, and £3.50 divided by 12 gives me a unit price of 0.292, rounded off to 3 significant figures. Next, let's have a look at the 1 pack of 8. Now that costs £2.64, and I get 8 cans for that, so that gives me a unit cost of 2.64 divided by 8 gives me 0.33 per can. So interestingly, the most expensive. You'd think it'd be the cheaper of the 2, but nope. And then finally, 2 pack of 8 costs £5, and altogether there are 16 cans in 2 packs of 8. So 5 divided by 16 gives me a unit cost of 0.31. Let's round that off to 3 significant, so 3 significant figures as well. 313. So now we've got our 4 different unit costs. Now it's clear now then that this one, 2 pack of 6, is the cheapest unit cost. Okay, so if it's cheapest to buy that per can, then it's going to be the cheapest price altogether. So what is the cheapest way of buying 48 cans? So we need to buy 2 packs of 6. How many times? That's going to be 12 cans, and 12 goes into 48 4 times. So the cheapest way of doing this is going to be to buy 4 lots of 2 times 6 pack. Beth sells hot dogs at a market. Each hot dog is a sausage in a bread roll. Hot dogs £3 each. The table shows her costs. Fees paid to the market £240. Bread rolls 42p per pack of 6. Sausages £2.50 per jar of 10. Other costs £57. Now it says that Beth sells the hot dogs for £3 each, and she sells 300 hot dogs, and we need to work out her total profit. Okay, well, our total profit is going to be total income minus total expenditure. So your money coming in less your money coming out. So we need to work out those 2 amounts, don't we? So let's work out income first. How much money she's got coming in. So we know how much money she's coming in from this part down here, don't we? Okay, so that's where we get our income from. Beth sells hot dogs for £3 each, and she sells 300 hot dogs. So that's quite simple. So income is going to be her £3 per hot dog times her 300 hot dogs. 3 times 300 is £900. So that was nice and easy. What about expenditure? So that was money coming in. What about money going out? Expenditure. So what has she got? So her total expenditure then is going to be the £240 from the fee paid to the market. She's got 42p per pack of 6 bread rolls. So how many bread rolls is she going to need then? If she's made 300 hot dogs, and bread rolls are in packs of 6. Then what's 300 divided by 6? 6 is into 300 go 50 times, so she's going to need 50 packs of those bread rolls. So that's going to be 50 times 0.42. Okay. Sausages, £2.50 per jar of 10. So 300 divided by 10 means I need 30 jars of sausages. So I need 30 jars at £2.50 each. And I've got 57 other costs. Okay, so then in total then, my total expenditure is going to be 240 plus 50 lots of 42 pence. So 50 times 0.42, that comes out to be £21. I've got 30 lots of £2.50, 30 times £2.50, that comes out to be £75. So my total expenditure is going to be those 4 amounts added up then, isn't it? So expenditure then is going to be 240 plus the 21 plus the 75 plus the 56. 24, 240, 21, 75, sorry, 57. £57 in other expenditure, which comes to 240 plus 21 plus 75 plus 57. That means total expenditure is £393. Okay, so what's her profit then? So profit is going to be income less expenditure, which is going to be her £900 that she made less the £393 that she spent. That comes out to be £507. So she's made a good profit on those hot dogs. £507. Between January 2015 and January 2016, the price of diesel increased from £1.12 per litre to £1.19 per litre. Calculate the percentage increase in price. Okay, now I tend to use this triangle when I do percentage questions. FOM, stick your thumb on it. F stands for final, original, and multiplier. Okay, and it's arranged like this into a triangle, FOM. Okay, so what does the F stand for? F stands for final, so it's the last price. It's going to be that one there, £1.19. It increases from £1.12 to £1.19. So £1.19 is the end price, or the final price. O stands for the original. Okay, so what was it to start with? It was £1.12 per litre, wasn't it? So that's our original price. That's going to be £1.12. And then multiplier, well, that's what we're trying to find, isn't it? Okay, so then what we do is we take our little FOM triangle, we cover up the one we want to find. I want to find the multiplier. And that tells me what to do with the other two. So multiplier, that's going to be the final price divided by the original price. Okay, so then subbing in the values I've got here. Final is £1.19. Original is £1.12. Okay, so then I just need to tap that into the calculator then. £1.19 divided by £1.12. That comes out to be 17/16 or 1.0625. 1.0625. Okay, now that's a decimal. To convert it into a percentage, you need to times by 100 or shift the decimal point 2 places along, so that's 106.25%. Now remember, we want to work out what the percentage increase is. Okay, so when you're doing percentage increases, you always start with 100%. So if I started with 100% and then now I've got 106.25%, that is an increase then of 6.25%. Okay, here are the interest rates for two bank accounts. We've got Northern Saving Bank, which is 2.5% per year compound interest, and Central Alliance Bank, which is 2.7% per year simple interest. Mia puts £6,400 in each account. Calculate the difference in value between the two accounts after 8 years. Give your answer correct to the nearest penny. Okay, so I'm going to work them out separately and then I'm going to compare them then. So let's start off with the Northern Saving Bank, NSB. So working out compound interests, the final amount is going to be the original amount times the multiplier raised to the power of the number of years. That's the formula for compound interest. So what is the final is what we want to find, isn't it? Original, what's the original? It is what she put in the bank account, which is 6,400. And the multiplier is going to be 100% plus 2.5%, which comes to 102.5%, which as a multiplier is going to be 1.025, then, isn't it? So that's the multiplier we're going to use here. So my final amount is going to be my original amount, which is 6,400 times by 1.025 raised to the power of 8. Now, tapping that into my calculator, because I can't do that sort of maths in my head. 6400 times 1.025 to the power of 8. That comes out to be £7,797.78. So I'm just going to write that down to the nearest penny. 7797.78. 7797.78. Okay. Now for the other bank account, that was CAB. Can just scroll up a bit, give myself a bit more space. So let's work out the second base now, CAB. CAB Bank. Again, the final is going to be original times multiply, but I need to find them a slightly different way here. Well, the multiplier part anyway. Final is just the same. The original is just the same. It's still 6,400. Multiplier. Now, I'm starting with 100%, and I'm going to be adding on 2.7% 8 times. So I'm just going to multiply that by 8 and work out one multiplier. So 2.7 in my calculator times 8, that comes out to be 21.6%. So add that to 100% is 121.6%, which as a multiplier is going to be 1.216. Okay, and then final amount, it's just going to be my original amount times my multiplier. Don't have to compound it this time, so I'm not raising it to a power, and I've already applied it 8 times. So it's just going to be a straightforward multiplication. So my 6,400 times 1.216, that comes out to be 6,400 times 1.216. I make that £7,782.40. £7,782.40. Okay, which you'll notice is slightly lower than the compound interest amount, which is, I suppose, the point of what we're looking at here, isn't it? So what is the difference between the two? Work out the difference between the two. So subtracting one from the other. So then the difference is going to be 7797.78 subtract 7782.40. What's that then? 7797.78 subtract answer. That comes out to be a difference of £15.38. 15.38. Okay, that's my final answer then. That's my difference to the nearest penny. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. Okay, so I tend to draw a line when I do these, and I mark the number I've been given. Now this is to the nearest centimetre. So on my scale, I'm going to go up 1 centimetre, so that would be 111, and down 1 centimetre, that would be 109. Now the numbers that round to 110 are the numbers that are going to be halfway or closer to 110. So there's all these numbers in here. These are the ones that round to 110, aren't they? And halfway between 109 and 110 is 109.5, and halfway between 110 and 111 is 110.5. So they're going to be my boundaries. Now notice really 110.5 would round up, which is why you've got this strictly less than sign in here. Work out cube root of 4096. Now this is a job for the calculator. Now your calculator, if you've got a scientific calculator, should have a cube root button of some sort. Sometimes it is written like this if you've got a cube root button. Some calculators don't have a cube root, but they have an X root button that you can use, or might have a little square like this. So one of those symbols there. Now luckily my calculator does have a cube root button, so I can just press shift and then that cube root button and then type in 4096 and then press equals, and it gives me the answer of 16. Now clearly you need to know how your calculator functions to find cube roots. Similarly, my next question is work out 3 to the power of 7. Now again, different calculators have a power key that's written slightly differently. Some of them are written like x to the n. Some of them have a little x and a little square where the power should be. Some of them just have like a little up arrow like that. Again, you need to work out which is your power button. Mine looks like this. I'm going to press 3 to the power of 7 equals, and my calculator gives the answer as 2187. 2187. Work out 512 divided by 5 to the power of 3 times 5 squared as a power of 5. Okay, I'm just going to use the fact that when I multiply two numbers with the same base, I subtract. When I multiply them, I add the indices, and when I divide them, I subtract the indices. So this is going to be the same as 5 to the power of 12 subtract 3 plus 2. So 12 subtract 3 is 9 plus 2 is 11. So that's equal to 5 to the power of 11. It's that one there. A linear sequence starts 11, 21, 31, 41, and so on. Okay, now if it's a linear sequence, it's going to have gaps in between that are equal, aren't they? So this is a plus 10 sequence. Can you see it's 10 between each numbers? And that means the nth term is going to be something like 10 lots of n. So where n is 1, 2, 3, 4, then 10n is 10, 20, 30, 40, and so on. But we've not got 10, 20, 30, 40. We've got 11, 21, 31, and 41. Now each of our numbers is one more than 10n. So we must have 10n plus 1. And that is my nth term, 10n plus 1. Simplify 3a plus 7b minus a plus 4b. Okay, so we need to collect like terms. So we've got terms in a, 3a minus a, and we've got terms in b, plus 7b and plus 4b. Now notice when I highlight those I highlight the sign that goes in front of them, because that is part of what we're doing, isn't it? So 3a subtract a is 2a, and 7b plus 4b is 11b. So we get 2a plus 11b. I've got a pair of brackets to remove. So I don't know how you remember this. It might be first, outside, inside, last. Might be something like that. Or you might have a smiley face, whatever way. You can work out that you have to multiply everything in the first bracket with everything in the second bracket. Y times y is y squared. Y times negative 4 is minus 4y. 5 times y is plus 5y, and 5 times minus 4 is minus 20. At this stage here, just look in the middle for your two like terms and add them up. So I've got y squared minus 4 and plus 5 make y. So my final answer is y squared plus y minus 20. Solve x squared minus 9x plus 20 is equal to 0. Now that's the same expression as we've got above. So I can just factorize it the same way. X minus 4, x minus 5 is equal to 0. Now when you have two things that multiply together and give you 0, it means one of them must have been 0 to start with. So either x minus 4 is 0, in which case x is 4, or x minus 5 is 0, in which case x is 5. So my answer is x equals 4, x equals 5. Two solutions. Solve the simultaneous equations 3x plus 2y is equal to 10 and 3x minus y is equal to 13. Now you notice that these two values of x, the coefficients, are the same. So this question lends itself very well to solving by elimination. So let's call this one equation 1 and this one equation 2. Then equation 1 subtract 2. So taking the second equation away from the first, so 3x take away 3x, they're going to cancel each other out, aren't they? Just take care when you're subtracting negative signs here. So 2y take away negative y is 3y, and 10 take away 13 is minus 3. So that's going to give me y is equal to minus 1. Okay, so now substituting back into one of our equations, substitute y equals minus 1 back into, should we pick equation 1? So then I've got 3x plus 2 lots of minus 1 is equal to 10. 2 minus 1 is negative 2. Taking that to the other side. So taking that over there, I'm going to get 3x equals 12. Give me x is equal to 4. So that would tell me that x is 4, y is minus 1. Always a good idea to check these just by subbing both values into the second equation, the other equation we didn't use. So 3x minus y equals 13. So 3 lots of 4 minus negative 1. Is that equal to 13? 12 subtract negative 1, 12 plus 1 is 13. So yes, it does work. Always a good idea to do checks in the exam. You'd better to find out in the test that you're wrong rather than when your results come back. Complete the table of values for y equals x squared minus x minus 2. So they've given you some of the values and they want you to find some more. Now it's usually a good idea to start with a positive end because that's a little bit easier to work out. And you might want to just double check your understanding by picking firstly a pair of values that you do know both of, just to make sure you understand what it is you're meant to be doing. So if I did input 3 into this function, I would get 3 squared minus 3 minus 2. 3 squared is 9, take away 2 is 6, take away 2 is 4. Yeah, so that's right. Okay, so that is what I'm going to be doing for each of these questions. So then if I put 2 squared in and I take away 2 and then another 2, 2 squared is 4, take away 2 is 0. Then I've got minus 2, minus 2. Can you see it's repeating itself? So that's probably the point where it turns around and starts going up. So I'm already thinking this is 0 and 4 here, but I'm just going to double check. So put minus 1 in, minus 1 squared minus negative 1 minus 2. Negative 1 squared is positive 1. Take away negative 1 is positive 1. So that's 1 plus 1. Take away 2 is 0. So yeah, that is 0. And then for minus 2, minus 2 squared minus negative 2 minus 2. Negative 2 squared is positive 4. Minus negative 2 is plus 2. So that gives me 6. Take away 2 is 4. Okay, so it is what I thought it was going to be. Right, so draw the graph of y equals x squared minus x minus 2 for the values of x from minus 2 to 3. So basically we just need to plot those points on. Minus 2, 4. Minus 2, 4 is up here. What's next? Minus 1, 0. Minus 1, 0. 0 minus 2. 0 minus 2, 1 minus 2, 2, 0, and 3, 4. Okay. Now this was a quadratic equation, so we were expecting a parabola, and that is what we've got. So I'm feeling pretty confident here that we've got it right. The last part is to draw a continuous curve passing through each of your points. You don't have to be Leonardo da Vinci, but try and get it to be as smooth as possible. What you don't want to be doing is put in like 2 marks on your paper. That will get marked down. Okay, and make sure you're using a reasonably sharp pencil. And make sure you go through each of the points. I'm a bit off on that one actually. It's good to go through the center of each one. Okay, 6c says write down the x-coordinate of the turning point of the graph. Now my turning point is this point here, isn't it? That's where the graph stops going down and starts going up again. Now we only want the x-coordinate, so just reading up to the line, I can see that that's going to be at a half. So the x-coordinate is a half. Interestingly, they don't want the y-coordinate here. Okay, but a straight line has gradient 4 and passes through the point 5, 23. Work out the equation of the line. Give your answer in the form y equals mx plus c. Okay, so we know that the equation of this line is of the form y equals mx plus c, and we're told here that the gradient is equal to 4, and that means m equals 4. So I know the equation already is of the form y is equal to 4x plus c then. So all I really need to do is find c. Now the second bit of the information tells me that my line passes through the point 523. So I can use that information. Passes through 523. So that's the x-coordinate there, isn't it? And that's the y-coordinate. So if we sub those into the equation, they should work because it's a point on the line. And then the only thing that I don't know there is going to be c then. So subbing those in, so 23 is equal to 4 lots of 5 plus c. What's that? Let's just multiply out those brackets. 4 times 5 is 20, isn't it? So I've got 23 is equal to 20 plus c. Let's just subtract 20 from both sides. It's going to leave me with c equals 3. So now I know all the pieces. I've got m, I've got c. I can write down the equation. It is y is equal to 4x plus 3. An athlete runs 240 meters in 45 seconds. Work out her average speed in kilometers per hour. Okay, well, I've got another triangle, handy triangle for distance, speed, time. This time I've got d on the top. These are alphabetical, d, s, t. Distance, speed, time. And again, I'm going to do it pretty much the same way as I did the percentage problem. Going to look at what I've got, what I haven't got, and then use the other two to work out the missing one. So an athlete runs 240 meters, so that's going to be my distance then, isn't it? 240 meters. So that's 240 m. Speed, well, that is what I want to find. And then time, 45 seconds. So that is 45 seconds. Okay, so then my speed, covering up the thing I want to find speed. That tells me what I have to do with the other two. So average speed equals distance divided by time. Now if I just go ahead and sub those numbers in, I'm going to sub in meters and seconds into this calculation, and it's going to give me an average speed in meters per second. But this particular calculation, we're being asked to put it into kilometers per hour. Okay, so before I sub these numbers in, I'm going to convert them into the right unit. So 240 meters, what's that then in kilometers? That's going to be, well, there are 1,000 meters in a kilometer. So I need to divide 240 by 1,000 then, don't I? That's going to give me 0.24. It's 0.24 kilometers. And then time, 45 seconds. What is that in hours? Well, it's going to be, there is a, 60 seconds in a minute and 60 minutes in an hour. So if I want to convert seconds into hour, I need to divide by 60 seconds and I need to divide by another 60 seconds. So what's that equal to? 45 divided by 60 divided by 60, 1/80th, which is 0.0125. Okay, so then subbing that in, distance is 0.24, time is 0.0125, so then 0.24 divided by 0.0125, that comes out to be 19.2. 19.2 kilometers per hour. Okay, so 19.2. An alloy is made from 28 centimeters cubed of copper and 41 centimeters cubed of gold. So those two amounts, they're actually volumes, aren't they, in centimeters cubed. So I know the volume of copper and the volume of gold. Now I'm told that the density of copper is 9 grams per cubic centimeter, and the density of gold is 19 grams per cubic centimeter. Work out the mass of copper used. Okay, so we need to know the formula that links density, mass, and volume. It's just density is equal to mass divided by volume. That's the formula. Okay, so in this case, I've been given the density, I've been given the volume, I want the mass. Rearranging that, mass is going to be density times volume, isn't it? So mass equals density multiplied by volume. Okay, so my density of copper is 9 grams per cubic centimeter. My volume is 28 centimeters cubed. It's a good idea just to check you've got consistent units when you're doing these sort of things. So density is in grams per cubic centimeters, and my alloy is measured in cubic centimeters. So if I combine these together, I'm going to get grams then, aren't I, for my mass? So 9 lots of 28 then. 280 minus 28, what's that? That's 252 then, isn't it? So 252 grams. Now part B says work out the density of the alloy. Okay, now to work out the overall density of the alloy, we need to know what the total mass is and what the total volume is. Okay, so the total volume is going to be the two. It's going to be the two volumes added together, then, isn't it? Okay, so we had a volume of 28 and a volume of 41, didn't we? So 28 plus 41 gives me a total volume of 69. Now the total mass, now we found the mass of copper already in the last question. It was 252. So we need to add on the mass of the gold. Okay, so we need to do mass calculation then, don't we? So to finish this off, we need the mass of the gold, don't we? So mass of the gold is going to be, remember it was density times volume, wasn't it? So the density of the gold times the volume of the gold. So 19 lots of 41. So that comes out to be 19 times 41. That's 779. So then the total mass is going to be 779 plus 252. Comes out to be 1031. Okay, so then the density of the alloy is going to be the total mass divided by the total volume. So 1031 divided by 69. What's that? 1031 divided by 69. 14.94. I'm going to round it off to 14.9. So 14.9 grams per cubic centimeter. It shows a polygon ABCDE, and that has been divided into 3 triangles. And we need to use the triangles to work out the sum of the interior angles of a polygon ABCDE, and we must show our working. Well, this polygon has got 5 sides, so it's actually a pentagon. So a 5-sided shape has got 3 triangles that go inside. Your maths teacher might have shown you how to derive the formulas for sum of interior angles of a polygon, and they do involve just dividing the shape up like this into triangles. You know that the angles inside the triangle sum to 180 degrees, so this triangle here adds up to 180 degrees. Now the triangle next to it also adds up to 180 degrees, its interior angles there. And finally our last triangle adds up to 180 degrees too. So you can see that those 3 angles there form that interior angle of my pentagon. And then I've got another one there, look, and another one there, another one there, and another one there. So the 3 sets of 180 degrees from my triangle add up to the interior angles of my pentagon. So let's write that down below. What are we going to write? Angles in a triangle sum to 180 degrees. So interior angle of ABCDE equals 3 times 180, which is 540 degrees. Okay. Here is a right angle triangle, and we need to show that x is equal to 12. Okay, so we've got 2 sides of a right angle triangle, and we're wanting to find a 3rd side. So clearly we are dealing here with Pythagoras Theorem. Pythagoras Theorem states that c squared equals a squared plus b squared, where c is the long side and a and b are the 2 sides. Okay, so we're just going to sub into there and find what c is, and then say that's what x is. So c equals a squared plus b squared. In this case, c is x. X squared is equal to 7.2 squared plus 9.6 squared. So on my calculator, 7.2 squared plus 9.6 squared comes out to be 144. So then x is going to be the root of 144, which is 12. Use trigonometry to work out the length x. I tend to remember ratios using the mnemonic SOHCAHTOA. Maybe you've got a different way. Maybe you can share it in the comments if you do. Right, so let's label up the sides. Here's my angle. This is the longest side, so that must be the hypotenuse. X is opposite my marked angle, and the other side is adjacent. Now, which ones am I using? I'm using the hypotenuse and the opposite, so the ratio I'm going to be using is sine. Okay, so the sine of my angle, sine theta, is equal to opposite over hypotenuse, which in this case, my sine 72 is going to be my x over 8. Rearranging for x equals, what we're going to do is move that 8 up there. So x is equal to 8 sine 72. Reaching for the calculator. Sine 72. Make sure your calculator is in degree mode. That could be a terrible, terrible mistake otherwise. Sine 72 times 8 is 7.608. I'm going to round that off to 3 significant figures. Does it tell me to do that? Nope. If it doesn't say, then 3 significant figures is usually a good one to go for. So I'm going to round that off to 7.61. If ABC is a right angled triangle, AB is 20, BC is 37. Calculate the angle BAC. BAC, that's that angle there, isn't it? If I go from B to A to C, so yeah, that angle between BA and AC. Okay, so that's the angle we want to find. I'm going to call it theta, which is my one for angles. It's my go-to variable that I label them with, so that's theta. Now, this is going to be a straightforward trigonometry question, isn't it? I've got 2 sides and I want an angle of a right angled triangle. Okay, so step 1, write down our mnemonic for remembering the various trigonometric ratios, which is SOHCAHTOA. You might have something else to remember it. Then we need to work out which one of our 3 ratios we're going to be using. Now, we label up our sides relative to the angle given. So this one is opposite theta, and this one is adjacent to theta. So we've got the opposite and adjacent. So that tells me that we need tan. Tangent is equal to the opposite over the adjacent. Okay, so I'm going to write down the formula for tan. Tan theta equals the opposite over the adjacent. Okay, then all we need to do is sub the values in from our diagram to work out the answer. So the opposite is 37, the adjacent is 20. Okay, so then theta is going to be the inverse tangent of that, then 37 over 20. Okay, so reaching for a calculator, we're going to use the inverse tangent button, which you have to access by pressing the shift key first. So shift, tan, and then 37 over 20. Okay, so what's that then? That is 61.6 degrees. 61.6 degrees. A water tank, which is a cylinder with radius 40 centimeters and depth 150 centimeters. We're told that it's filling at a rate of 0.2 liters per second, and we're being asked, does it take longer than an hour to fill the tank? Well, in order to answer that question, we need to know what the capacity of the cylinder is to start with. So let's do that first. What's the volume of this cylinder? Well, a cylinder is a prism, and the area of a prism is equal to its cross-sectional area times its length, or its height. So we need to work out what this bit is here. Okay, now that area is a circle. It's pi r squared times the height. So the volume of this is going to be, well, that's pi r squared, isn't it? So the volume of this cylinder is going to be pi r squared h. I'll leave the pi in for now. Do I want to leave the pi in? No, let's put it in. 3.14 times 40 squared times 150. So what's that? 3.14 times 40 times 40 times 150. So that's 753,600. Now that's in cubic centimeters. Now we're told, we should really know this, but 1 litre is 1,000 cubic centimeters. So if it's got a volume of that, then it can hold, let's divide that by 1,000 and find how many litres it can hold. So that's 753.6 litres. Okay, so if it's filled at a rate of 0.2 litres per second, how many seconds does it take to fill up? So time taken to fill up is going to be the volume divided by that flow rate then, isn't it? So taking time is equal to 753.6 divided by 0.2. And that equals 3,768 seconds. 3,768 seconds. Now, this question is asking about time in hours. So we need to convert that to hours. So time in hours is going to be the seconds divided by 60 to get minutes, and then another 60 to get hours. So 3,768 divided by 60 divided by 60 is 1.046 reoccurring, which I'm going to round off to 1.05. So that's 1.05 hours. Okay. So, does it take longer than 1 hour to fill the tank? Well, yes it does, because it takes 1 hour and 5, or 1 hour at 0.05. So the answer is yes. It takes longer than 1 hour. A cube has edge length 0.9 meters. Work out the total surface area of the cube. Give your answers in square centimeters. Okay, so notice first that that's in bold, and normally things in bold are there because students will otherwise not see them. So just take extra care when things are in bold. So square centimeters, this measurement is in meters we've been given up here, so we need to convert that into centimeters first, and if we're going to work this out in centimeters. So let's convert that to 90 centimeters. So this is 90 centimeters by 90 centimeters by 90 centimeters. Okay, now a cube is made up of 6 equal faces, and each face is a square, and 90 times 90 is the area of each square. So the total surface area of this cube is going to be the area of one face, which is 90 times 90, times by the number of faces, which is 6. So we're going to find 6 faces, and each face is 90 by 90. So the total surface area is going to be 6 times 90 times 90. So tapping that into the calculator, 6 times 90 times 90 gives me the answer of 48,600 centimeters squared. 48,600 centimeters squared. Okay, let's just write it down in the bottom. Oops, let's write in the bottom properly. Triangles A, B, and C and D, E, F are similar, and we've got them shown here. Now it says work out the value of x. Now, if two shapes are similar, it means their sides are in the same ratio. So these two sides match up on my diagram, and these two sides match up. And if we have a look at the relationship between 3 and 6, that's times 2, isn't it? So the 6 is twice as big as the 3. So it's got to be the same here from here to here. It's got to be times 2 as well. So whatever x is, when I multiply it by 2, I'm going to get 9. In other words, x is 9 divided by 2, which is 4.5. Okay, so that's my value of x, it's 4.5. And then it says write down the size of angle y. Well, as well as all the sides being the same ratio, in similar shapes all the matching angles are going to be the same, so that one and that one actually match up, don't they? So I know straight away that y must be the same angle. It must also be 53, so that needs to be 53 degrees. On the grid, draw a shape that is a reflection of the shape y. Show your mirror line. Okay, so they haven't actually drawn a mirror line on for us, so we've got quite a lot of freedom for this question. So let's pull out a ruler and draw on a mirror line for ourselves. I'm going to draw the mirror line here. Okay, and then let's reflect each of the points. When you're doing a reflection, you should really take each point in turn and work out where its reflection goes. So this point is 1 unit away from the mirror line, so its reflection will be 1 unit away. This point here is 3 units from the mirror line, so its image is going to be 1, 2, 3 units away as well, and so is that one at the top, and it's going to be 3 units away. Okay, once we've got all the corners, we can then draw the lines in. Like so. And then we have our reflection. Now I say, as long as you've reflected it in a mirror line and drawn your mirror line on, you should get the mark for that. The table shows information about the distances walked by 120 students on their way to school in 1 week. And you can see that we've been given a grouped frequency table for those distances. So I've got 0 to 5, there are 20 students who walk between 0 and 5. 48 students walk between 5 and 10 miles, 30 students walk between 10 and 15 miles, and 22 walk between 15 and 20 miles. Now we're asked to work an estimate of the mean for this data. Now the problem is that this data has been grouped, so we don't have the precise values, but we're estimating, so we're going to use mid x as an estimate for each of these. So you find mid x by adding your two n values together and dividing by 2. So 0 plus 5 is 5, divided by 2 is 2.5. You're basically averaging out the two endpoints. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divided by 2 is 12.5. And 15 plus 20 is 35, divided by 2, 17.5. Okay, once you've got the mid-x, then we can work out f times x. So grabbing the calculator, 20 times 2.5, that gives me 50. 48 times 7.5 is 360. 30 times 12.5, 375. And 22 times 17.5 give me 385. Oops. Okay, and then just need to add all those up to get a total. So 385 plus 3.75, sorry, 375 plus 360 plus 50. That gives me a total of 1,170. 1170. So then my mean then, my estimated mean, is going to be my sigma fx divided by my sigma f. In other words, the sum of fx, which is this value here, 1170, divided by my sigma f, that's the sum of my frequencies, which is this value, 120. Okay, just type that into the calculator again. 1170 divided by 120 is 9.75. Okay, so that's my answer, 9.75. In 1 hour, the shop sells 180 scoops of ice cream. The number of scoops of each flavor is shown in the table. Okay, so 45 scoops of vanilla, 75 scoops of strawberry, and so on. Now, we need to show this information in a pie chart, but before we do that, we need to work out what angles and things that we're going to use. So before we get onto the pie chart, we've got some work to do on the table first. Now, we've already told what the total was. The total number of scoops was 180, wasn't it? Okay, so 45 plus 75 plus 50 plus 10, that's 180. Now what we want to do is we want to take those number of scoops and turn them into the number of degrees that we need to draw on the pie chart to represent them. Now in a full turn, you've got 360 degrees, haven't you? So the angle that we're going to use to show this needs to add up to 360. Now you'll probably notice straight away that 360 is twice as big as 180. So that means we can use 2 degrees to represent 1 scoop of ice cream that was sold. Okay, so that makes it very easy to work out the various angles that we need to use. We just need to double up then each of these. So my 45 scoops of ice cream, if I'm using 2 degrees per scoop, that's going to be a 90-degree angle that we're going to use. Strawberry, 75 times 2, that's a 150-degree angle. Chocolate is going to be a 100-degree angle. And mint is going to be 20 degrees. Okay? Okay, so moving on to the pie chart now. We've been helpfully given one of the lines to start off with. So this is going to be like one of the lines for our vanilla sector. Now vanilla was a 90-degree angle, so if we lay our protractor along that starting line with the center of protractor right at the end of the line in the center of the circle, we should be able to count around to 90, draw a mark, then remove the protractor, and then draw on our 90-degree angle line. Okay, so that was 90 degrees, wasn't it? Okay, so this was then vanilla. Right, now the next angle we need to draw is 150. So again, we're going to take the protractor, but we're going to lay it on top of our newly drawn line, so the second vanilla line, and we're going to count around to 150. We're going to make a little mark, remove the protractor, and then join up the line that we made. Okay, so 150. It's going to be there then, isn't it? Okay, so then that is my strawberry section. That was 150 degrees. The next section was our chocolate degree thing, and it was 100 degrees. So again, we're going to lay the protractor along our last drawn line with the center of the protractor at the center of the circle. We're going to count up to 100, make a little mark, remove the protractor, and then we can draw our line in. Okay, so that was my chocolate section, and that was 100 degrees. Okay, and now the mint section, it kind of draws itself. Okay, so it's just the leftover part, isn't it? But you might just want to double check that that angle there is 20 degrees. So if you measure it, and it should be there or thereabouts. If you're like a degree either way, it's not going to make much difference. But just double check that it's there or thereabouts for 20. Okay, and that's that. We're done. The scatter diagram shows the results of 10 of the people in Lee's experiments. Here are the other 2 results. Okay, so I've got 2 more people to add. One was 47 years of age and took a time of 21 seconds. And the other one was 60 years of age and took a time of 34 seconds. So I need to add these to the scatter graph. Just make sure you're clear about the scale before you start plotting points. you can see from here to here there are 10 divisions, aren't there? So each one of those little squares is going to be worth 1, and the same up here as well. You've got 10 divisions spanning a gap of 10, so each one is worth 1. So a nice easy scale to use. So just find 47 on my scale this way and read up and read across from 21 and mark our cross. Okay, there's a cross there. And then the next one is it's 60 and 34. 60 and 34. 1, 2, 3, 4. There. Okay. Right. So now I've plotted those points. Part C says, what type of correlation is shown in the scatter diagram? Okay, if I get my ruler out, you can probably see that I've got a kind of band going up the data like that from left to right, sloping upwards. So got a clear positive correlation here. So I'm just going to write down the word positive. Question D. Estimate the time it would take a person aged 35 to complete the puzzle. Show your working to justify your answer. Okay, well, my working is going to be on the scatter diagram itself. Okay, so coming back to the diagram, if I put a line of best fit up my graph, just trying to angle it so you've got the same number of points on either side of your line. Something like that. Doesn't have to go through the origin, so don't force it through there. Something like that. You do get a bit of leeway when you draw these points. Probably it's like anywhere that this end is anywhere between there and this one is anywhere between there, and you usually get the mark, so it doesn't have to be an exact science, but a reasonable attempt at drawing your line of best fit is required. Okay, so once we've got our line of best fit, we can use it to help estimate our value. So I'm going to find 35 years of age on my diagram, and I'm going to read up to the curve and across. Okay, so there's 35. Reading up to the line. When I hit the line, I'm going to change direction and read across. And I'm reading that as about 11 on my scale. Okay, so estimate the time it would take a person aged 35 to complete the puzzle. It would take them 11 seconds. Part E says, Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. Is Lee correct? Show working to support your answer. Now, coming back to the diagram, if I put my ruler at 30, we can then count how many people are below it then, can't we? So how many is that then? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 people are below 30 seconds, aren't they? And we've got 3 above that line there. Okay, just going to draw a kind of a dotted line along there to show our method. Okay, so we've got 9 out of 12 then, haven't we? Okay, so what's that as a percentage? 9 out of 12 as a percentage. Well, I just need to tap that into my calculator, don't I? 9 divided by 12 times by 100% to turn that into a percentage. So 9 divided by 12 times 100 comes out to be 75%. So, is he correct? No, it's not at least 80%, it's 75%. So Lee is not correct. The 4 possible outcomes of an experiment are A, B, C, and D, and we're told that the probability of A is 0.28. We're told the probability of B is twice the probability of A, so that's going to be 2 times 0.28. What's that? 2 times 0.28, that is 0.56. And we're told that the probability of C is equal to the probability of D. Okay, so we've got the events A, B, C, and D. Okay, so that is our outcome, and this is the probability. So we know that A is 0.28, we know that B is 0.56, and we want to work out, we know that C is equal to D. We don't know what those are. Let's call them X and X. Okay, and we want to work out what X is then for the probability of D. Now, because of probability, one of those things must have happened. All of those probabilities need to add up to 1. So if I take 0.28 and I add 0.56 and X and I add it together, I should get 1 for completeness. So let's add like terms together. What is 0.28 plus 0.56? 0.28 plus 0.56 is 0.84, so 0.84. X plus X is 2X plus 2X is equal to 1. So I've got myself a little linear equation in X that I can now solve. So taking my 0.84, moving to the other side of the expression, I'm going to get 2x is equal to 1 subtract 0.84, which is 1 subtract 0.84 is 0.16. So I know that 2x is 0.16. So then x is going to be 0.16 divided by 2. So divide that by 2, and I'm going to get 0.08. That doesn't look right. Yes, it does. 0.08. So that is going to be my value of D and C. And our answer wants us to find the probability of D. So that's 0.08, one of the x's. This is a Venn diagram, always my favourites. A school has 86 teachers, 42 are male and 44 are female. 1/3 of the male teachers have blue eyes and 1/4 of the female teachers have blue eyes. So we're going to put that on a Venn diagram. For A, we're told that the universal set is teachers in the school. M is the male teachers and B is the teachers with blue eyes. We need to complete the diagram. Okay, so where shall we start? I think if we look at this bit here, 42 are male and 1/3 of the male teachers have blue eyes. That means we can work out what the intersection is going to be then, don't we? So we've got 42 male teachers altogether and 1/3 of them have blue eyes. So 42 times 1/3, or 42 divided by 3. 3 goes into 42. Is that 14 times? So that means there are going to be 14 male teachers with blue eyes. So that means the intersection between M and B is going to be 14. And now I can start working out the rest. So if there were 42 male teachers altogether, of which 14 had blue eyes, then 42 subtract 14 will be the number of teachers who are male and don't have blue eyes, which is 28. 1/4 of the female teachers have blue eyes. How's that going to help us? Oh, okay, I suppose that tells us the bits that are in the number who are in B and not in M. And we know there are 44 female teachers, and 1/4 of that would be 11. So that is that one there then, isn't it? So 11 teachers have blue eyes and are not male. And now we can work out what's left. We've got 86 teachers altogether. So then 86 minus my 3 other parts, 28 and 14 and 11. So that's 42 plus 11, 53. 86 to subtract 53, which is 33 female teachers with not blue eyes. That's what's going to go there, isn't it? Part B says one teacher who has blue eyes is chosen at random. Work out the probability that the teacher is male. So we want the probability that the teacher is male given that they have blue eyes. In other words, if we know that the teacher is in this group, what is the probability then that they are here? So that's going to be, there are 14 teachers with blue eyes out of a total population of 25 teachers with blue eyes. So that is going to be 14 over 25.
Well, that was a long session. Well done for getting all the way through to the end. Please do like and subscribe if you found it helpful, and share the link with your friends. This really helps the channel out. Past paper practice is one of the best forms of revision in the run-up to the exams. So be sure to check out my past paper walkthroughs by checking out the playlist linked on your screen. See you on the next video.